Some metals react violently with other chemicals, and others don't seem to react at all. By observing chemical reactions, we can tell a lot. They can even help us group elements together.
Now, we're off to the lab to experiment with 4 different metals. Sodium, magnesium, potassium, and calcium.
Okay.
Well, what's the experiment?
We'll see how metals react with distilled water and group them according to the results.
So what are we looking for?
We'll see some kind of change, such as bubbles of gas being released.
Okay, I'll record the results.
Sounds like we're ready. For this reaction, we cut off a small piece of sodium metal. See the shiny surface?
Yeah.
We'll put the rest back in safe storage. And put our slice into the water.
Whoa, look at it go.
Definitely a reaction, lots of bubbles.
Do the bubbles bring the sodium up to the surface?
The bubbles act as pontoons or life jackets and keep the sodium floating at the surface.
Magnesium metal in water. Here it goes.
Can't really see any bubbles.
Not much happening as far as I can tell.
The magnesium sank straight to the bottom with no bubbles throwing it up.
Does this mean that magnesium is non-reactive?
We have to be careful here. There might not be enough energy available to get a rapid reaction going.
We could add heat from boiling water.
Excellent idea. Let's try it.
There it goes. I can see bubbles.
That's what happens when we increase the available energy.
Still a pretty slow reaction, though.
Okay, let's put in our slice of potassium metal.
Lots of bubbling. Oh, neat.
Like a pinball.
It's burning. It looks like there's a purple flame there.
Let's see what calcium metal does in water.
Not much happening.
We should add some energy to see if it makes a difference.
Okay, let's try it.
Whoa, there it goes.
Definitely some bubbles.
But not too fast of a reaction. The calcium stays at the bottom.
Okay, so based on what we've observed, are there similarities in the reactions that help us group these elements?
Well, all the metals we tested react with water.
They all gave off gas bubbles.
Potassium had the most violent reaction.
Yeah, it actually looked like it was on fire.
But sodium had a pretty strong reaction, too.
With the bubbles bringing it up to the surface.
And they both reacted without adding extra heat.
So you put potassium and sodium in the same group?
Sure.
And what about calcium and magnesium?
Well, they both needed extra energy before we could see a reaction.
And there weren't enough bubbles to bring them up to the surface.
And the bubbles were slow to form.
Which means they're not nearly as reactive as sodium and potassium.
So, they'd probably go in a separate group.
Good work.
We've got all these elements trapped inside these stars, but a small amount of stars, the supermassive stars that are about 10 to 100 times the mass of the Sun, end their lives violently as the core of the star runs out of that nuclear fuel that's keeping the star going. The star then collapses in on itself, and the rebound of that collapse causes a supernova explosion. The explosion hurtles out all those elements that were made inside the star, and those elements can then go into interstellar space, form other stars, planets, and even you and I.